Okay, yesterday we talked about dividing many terms by one term and dividing many terms by many terms. You get an assignment on page 75, working problems of these types. Are there any there you had difficulty with, any you'd like to see worked? Yes, Mo Doopy. Number 27. This is an example of dividing many by many, and it's a beautiful problem. Page our divisor is a squared plus 3a minus 1. Now our dividend. Remember, our dividend must be in proper sequence in each term accounted for. Well, is that in proper sequence and each term being accounted for? The answer is no. If you take a look at that problem, you start off with 4a to the fourth. After a to the fourth should come a to the third. Do we have any there? Yes, we do. We have a positive 3, a to the third. After a to the third should come a squared. We don't have any. So we put a 0 in as a placeholder. Again, if you want to, write it 0a squared. After a squared is a, we have one of those, negative 2a. After a is a term that contains no a, that's positive 1. So there we're ready to work. Everything's in proper sequence. We take the first term of our dividend, that's 4a squared, a to the fourth, divided by the first term of our divisor, which is a squared. Remember, this is a short division problem. Sign, coefficient, one letter at a time. Well, you come out with 4a squared. That becomes part of your quotient. We now multiply each term in our divisor by this 4a squared. So that gives us 4a to the fourth. We get a positive 12a to the third. We get a negative 4a squared. We then subtract. All that means is change all the signs. Notice the first term goes out. All the way down the line, the first term goes out. We have a positive 3a to the third, and a negative 12a to the third is a negative 9a to the third. Automatically, the negative sign goes up there. We have 0 and a positive 4a squared is a positive 4a squared. We bring down the next term, which is negative 2a. We go through it again. We take the first term of our dividend. We don't worry about the sign because we already have the sign up in the answer. We take the first term, that's 9a to the third. We divide it by the first term of our divisor, which is a squared. Well, we get 1 into 9 is 9. A third over a squared is 8. That means we're going to multiply each term in our divisor by this negative 9a. We get negative 9a to the third. We get a negative 27a squared. And we get a positive 9a. We subtract what there. That means change the signs. They go up. We have a positive 4 and a positive 27 is a positive 31 a squared. Again, automatically we have the sign of the next term in our quotient. We have a negative 2a and a negative 9a is a negative 11a. We bring down the next term. Again, first term of our dividend, 31a squared, divided by the first term of our divisor, which is a squared. That gives us 31. We're going to multiply each term over there by 31. If we do that correctly, we get 31a squared. We get a positive 93a. We get a negative 31. We subtract. They go up. We have a negative 11a and a negative 93a is a negative 104a. We have a positive 32. There are no more terms to bring down. We're done with this problem. This represents our remainder. We write it as negative 104a plus 32 all over a squared plus 3a minus 1. And there is your answer. Yes?
Is there any problem with writing it? Okay, you put the negative.
Yes.
I just put negative after 31. The book has plus negative.
Yeah, well, either way.
Okay.
Either way.
Doesn't matter.
No, no. Okay? That's a long division. And this was about as hard as they get. Any questions? Okay. 23. 23. We did in class yesterday. No, we didn't. Almost. Almost. This is x minus 2 divided into x to the 4th minus 1. Well, how many zeros are we going to have to add? 3. This is almost the same as the problem we did in class. Same divisor. What is that, negative 1 at the end? The only thing is going to be different. Our answer is going to be the same. Our remainder is going to be different than yesterday because the last term is different. That's the only reason. We take x to the 4th divided by x. That gives us x to the 3rd. We multiply each term over there by x to the 3rd. We get x to the 4th minus 2x to the 3rd. We subtract. Change the signs. First term goes out. We have a positive 2x to the 3rd. Positive sign goes up into our quotient. We bring down the next term, which is 0. We now take 2x to the 3rd and we divide it by x. Well, 1 into 2 is 2. X to the 3rd divided by x is x squared. We're going to multiply each term by x squared. If we do, we get 2x to the 3rd minus 4x squared. We subtract. Change the signs. We have a positive 2x cubed and a negative 2x cubed. They go out. We have 0 and a positive 4x squared is a positive 4x squared. The positive sign goes up in our quotient. Bring down the next term. That's a 0. We have 4x squared. We're going to divide it by x. That gives us 4x. We're now going to multiply each term in our divisor by 4x. If we do, we get 4x squared. We get a negative 8x. We subtract. Change the sign. First term goes out. We have 0 and a positive 8x is a positive 8x. Positive sign goes up in our quotient. We bring down the next term, which is negative 1. We now have 8x, and we're going to divide it by x. Well, 1 into 8 is 8. X divided by x, that's 1. That's good. So we get 8. We're going to multiply each term by 8. We have 8x, negative 16. We subtract. We have a negative 1 and a positive 16 is a positive 15. There are no more terms to bring down. We're finished with the problem. The 15 represents our remainder. We write it as 15 over x minus 2. And there's the final answer.
I saw in the book that it said negative 15. That's what it was.
Is that right?
I had it all right.
Check the answer book.
You were fine.
Every so often. Okay? Let's go on. Now, if we had the problem 3 times 4x minus 5, and I asked you to multiply this, remove the parentheses, distribute, they all mean the same, what would you get for an answer? What would you get? Michael? 12x minus 15. What this is, this represents the product of these numbers right there. The product means we multiply. Now, anything we learn to do in math, we have to learn how to undo. So what I'm going to do now is I'm going to give you a product and ask you where it came from. I'm going to ask you to find its factors. Factors. And that's the name of the game now, factoring. The first type of factoring we're going to talk about is factoring by extracting a common factor from each term. Example. Let's suppose I have 20a minus 15b plus 30c. And I want to see if this is factorable, if I can extract, if these terms have any factors in common that I can extract. Kathy?
5.
A 5. Now all these numbers are divisible by 5. So we're going to extract the 5. Kathy, if we extract the 5, what is going inside the parenthesis?
4a
4a
minus 3b plus 6c.
plus 6. Okay, 4a minus 3b plus 6c. That's correct. My question is, Kath, is this. Once you determine what goes outside, what you are extracting, how do you find out what goes inside that parenthesis?
Multiply by 5.
No, I don't think so. I don't.
5 goes into 20a.
Yeah, what you do is you divide each of the original terms by what you have extracted. So we can extract the 5. We're going to divide each term by 5. Notice what we have. We're dividing many by 1. That's what we have for homework today. We're putting it to use. If we do that, we have 4a, negative 3b, positive 6c. Now, the arithmetic is your responsibility. You should recognize the largest number that divides evenly into all those numbers. Let's suppose I have this problem. 2x to the 5th minus 5x to the 3rd. Question. What can we extract there? Tony?
X squared.
X squared. Everybody agree with x squared? BB?
X to the 3rd.
X to the 3rd. Well, let's see who's correct. Now, letters, in order to extract a letter, it's a lot easier than the numbers because it's right there in front of you. In order to extract a letter, each term must contain that letter. Well, each term has an x, so I can extract an x. Question is, how many? Well, always the what? The lowest number. So you can extract the x along with its lowest exponent, which is x cubed. You see, this has an x cubed in it, this has an x cubed in it, I can take it out. So this is what we are extracting. We now have to determine what goes inside the parenthesis. We divide each term by what we have extracted. Short division problems again. This is what you have for homework. Very important. Well, 1 and the 2 is 2. You have an x to the 5th divided by x cubed, you get x squared. Negative. 1 and the 5 is 5. The x cubes divided by x cubed is 1. We don't have to write it. There's our answer. To check it, if you want to check it, just multiply it on. You should come out with what you started with. Okay? Let's try some. Let's suppose we have 21 x squared y to the 7 minus 15 x to the 3rd y to the 5th plus 6 x to the 4th y to the 3rd. I'll repeat that. That's 21 x to the 2nd y to the 7th minus 15 x to the 3rd y to the 5th plus 6x to the 4th y to the 3rd. Okay, Roy, what did you find to take out?
Out.
Yes.
3x squared y to the third.
Okay, he says 3. That's arithmetic. The largest number that divides evenly into all these coefficients is 3. So we can extract the 3. Now he said we could take out an x squared. Well, in order to take out a letter, each term must contain that letter. Notice each term has an x in it. So we can extract the x along with its lowest exponent, which is 2. Likewise, each term contains a y. So we can extract the y with its lowest exponent, which is 3. So this is what we are extracting. Now once we know what we're taking out, to determine what goes inside the parenthesis, we stated we had to divide each of these terms by what we have extracted. So we're going to divide each of these terms by 3x squared y to the third. This is what we have extracted. If we do this correctly, Roy, what are we going to get inside the parenthesis?
7y to the fourth minus 5xy squared plus 2x squared.
Beautiful. As you can see, this is just a series of short division. You know how to do that. Okay? Let's try this one. Let's suppose we have 28 a squared b to the fifth c squared minus 20 a to the fourth b to the fourth c plus 8 a to the sixth b to the third. That's 28 a to the second b to the fifth c squared minus 20 a to the fourth b to the fourth c plus 8a to the sixth b to the third. Okay, for this particular problem, Anthony, what did you extract?
4a squared b cubed.
4a squared b cubed. Well, the arithmetic, we have a 4 definitely. Now remember, in order to take out a letter, each term must contain that letter. Well, each term has an a in it. So we can extract the a with its lowest exponent, which is 2. Next letter is a b. Again, each term has a b in it. We can extract that with its lowest exponent, which is 3. Next we have c. Hey, each term does not contain a c. Therefore, we can't take it out. So this is all we can take out. We're now going to divide each term of the original expression by what we have decided to extract. If we do this correctly, what do we get, Tony?
7b squared c squared minus 5a squared bc plus 2a to the fourth.
Beautiful. Are there any questions on how he got what he had inside? Just short division. Let's try this problem. let's suppose I have 2x to the 5n minus 7x to the 4n plus 3x to the 2n. Okay, Hung.
S
What-
square,
X-
S square n.
Okay, we read that as x to the 2n. Notice, there's no number greater than 1 that will divide evenly into these numbers. We can't extract a number. A letter. In order to extract a letter, a variable, each term must contain that variable. Each term has an x. So we can extract the x along with its lowest exponent. Well, we have exponent 5n, 5 times n, 4 times n, 2 times n. Which one is the smallest? Well, it's 2n. So this is what we are extracting. We're now going to divide each term by x to the 2n. If we do this correctly, what do we get?
2s to the third minus
2x to
7s,
what?
to the third. Minus 7s to the square plus 3.
Everybody agree with that?
No.
No, I don't agree.
Minus.
Put up the M.
Hey, he forgot the n.
Oh, yeah.
Remember what we do. Anytime we divide like bases and they have different exponents, we're going to end up with that base. And we subtract the exponent.
Yeah.
5n and a negative 2n, well, that's 3n. That didn't change. And there's our answer. Be careful. One more of these. Let's suppose we have, let's see, 5x to the n plus 2 minus 4x to the n plus 1 plus 11x to the n. I'll repeat that. That's 5x to the n plus 2 power minus 4x to the n plus 1 power plus 11x to the n power. Okay, this should be interesting. Should be interesting. Madupi, what did you find in common to these three terms that you could extract? What factor do they have in common? X? X to the m power. Sure. Does everyone see that? There's no number that we can extract. Each term has a letter. x in it, so we can extract the x with the lowest exponent. Well, the lowest exponent is m. So we're going to extract x to the m. That means we're going to divide each term by x to the m. Madupi, what am I going to get here now? 5? Good start. 5 what?
5x to the 1 power.
5x to the
1 power.
1 power. No. Let's take a look, Madu. We have same base, right? Anytime we divide like bases, they have different exponents. So we're going to keep the base. What are we going to do with the exponents? Oh, I don't think so. Suppose I have x to the 7th divided by x to the 3rd. What do I get for an answer, Madupi? What did you do with the exponents? Well, you subtract it. You do the same thing here. You have to subtract the exponents. Well, what does subtract mean to do? It means add the opposite. So we take n plus 2. We add the opposite of that. The opposite of n is negative n. Combine those terms. What do you get, Madupi? 2x squared minus 4, right? Now we have an x on top, an x on the bottom. We're going to end up with an x because they have different exponents. Question is, how many are we going to end up with? Well, 1, sure. We take the exponent and numerator, n plus 1. We add the opposite of n, which is negative n. That's what subtract means. They go out, we get 1. We don't have to write it. Plus. Finish it up. 11, sure. You see here we have x to the n over x to the n. We said anytime we have like bases, same exponents, that's 1. Okay? One more problem. Let's suppose I have a times the quantity, x minus y, minus b times the quantity, x minus y, plus 3 times the quantity, x minus y. Okay, BB, I have some questions. My first question is this. How many terms are represented in this problem? How many terms are there in this problem? How many terms do you see?
3.
3 terms. Very good. We have 3 terms. 1, 2, 3. My second question, Beeb, is are there any common factors that we can extract? Is there something common to all 3 terms that I can take out?
Quantity x minus 1.
Yeah, because you see this time, instead of extracting a number or a letter, we're extracting a whole parenthesis. Now, the same game still applies. Once you determine what goes outside, to get what goes inside, you divide each of the originals by what you have extracted. So we're going to divide each of these 3 terms by x minus y. If I do that correctly, B, what am I going to get for answer?
A minus b plus 3.
A minus b times 3 plus 3 times the quantity x minus y. Nice and easy. Okay? Now, we're into factoring. And I like to teach factoring by the number of terms involved in the expression. How many terms do we have in our algebraic expression. So today we're going to talk about factoring.